how do we graph exponentials? So what does an exponential look like? What does the function look like? And it looks like this. We have a base, and in the exponent is a variable. So very simply, if the variable is in the exponent, we call it an exponential function. How do you know if it's exponential? The variable is in the exponent. Does it mean if there's a number in the exponent, does that make it exponential? No. What makes it exponential? The variable is in the exponent. And then what do we call the large number that's connected to the exponent? We call that the base. So we have a function with a base to an exponent. So that base can change and then changes the curve slightly. Now, if I asked you to graph f at x equals 2x, what would you do to graph it? Well, because you don't really remember, you might do a table of values. No one got you a packet? It's not very nice. What would be an obvious number to put in for x? 1. Let's do it. What's 2 to the 1? So if I plug in 1, the answer is 2. I can do that. What's another one? Because I think you're forgetting what the curve looks like for an exponential. Remember that we've done polynomials, we've done rationals, we've done radicals, we're going to do exponentials, logarithms. Like there's going to be a library, right, that you need to practice and remember. What's another great number I could put in for x? 2, why not? So, what's 2 squared? Let's go. What's another number I could put in? 3? All right, we're going to start getting like a little high, right? So 2 cubed is what?
8.
I don't know. We'll try. 1, 2, 3, 4, 5, 6, 7. Whoa, we just made it. Let's go not past 3. What other number could I put in? Is 0 allowed, or is it undefined for an exponential? 0 is allowed, right? Mean any base to the exponent 0 always equals 1 before you tell me the wrong answer. Any base to the exponent 0 always equals, what's negative 1 to the 0? What's 1 billion to the 0? What's 1/2 to the 0? What's negative 1/4 to the 0? What's root 3 to the 0? Get what I mean? Any real number to the exponent 0 always equals 1. Did anyone want to say the wrong answer? Don't say it. It equals 1. Now, are negative numbers allowed for exponentials, or is that undefined? So I'm going to put 0, 1 here. Is that okay? Right there. Are negative numbers allowed? Yay, I agree. So, what happens when you have 2 to the negative 1? So, do you know what your brain wants to do? Don't do it. Your brain says it's got to be a negative number, right? 2 to the negative 1. I see a negative. The answer is negative, right? You're going to stop it, right? A negative exponent means you do the reciprocal. A negative exponent means the reciprocal. The negative exponent means the... So what's the reciprocal of 2? So, can you find where negative 1.5 is? Let's just do another negative 1 for fun. Negative 2. So, if you know that 2 squared is 4, what does the negative do? Do the reciprocal of 4, which is 1/4. Are you now getting a sense of what you did last year? What does the picture of an exponential look like? So, I'm going to ask you a really important question. Is there any exponent I could put in that would give me the answer 0? No. Is there any? If I put in a negative exponent, how about if I put in negative 1 billion? Would that give me the answer 0? No, right? In fact, every answer you get will always be positive. Every answer you get will always be positive. Therefore, at 0, we have an... So, for an exponential, we have an asymptote at 0 that shows that the whole graph is above 0. Does it include 0? No. It's all above 0. And what does the curve of an exponential look like? Well, you know an exponential, does it increase rapidly or does it increase slowly? Exponential. Something's growing exponentially. Does that mean it's growing rapidly? Growing slowly. Rapidly. So can you see to the right what's happening? It's going rapidly going up to heaven, yes? And then what happens to the left, though? Now, there's no room on here for this, but we'll talk about it. If I asked you for the end behavior, where would you say the right end behavior is? Not heaven, but infinity. What would you say the left end behavior is? This might. So the right end behavior is infinity. Look carefully. Whoa! Look carefully. Where's the left end going? Correct. The left end is getting closer to. Does this left end go to any negative numbers? Is it getting closer to negative infinity? No, it's getting closer to what number? Will it ever get there? So it's a tragic love story, right? They get closer, 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 right? Hallmark movie would never, ever, 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 ever meet, right? So, this is called an exponential growth model. Growth means it's increasing over time. When I look left to right, what is this function doing? Increasing. An exponential is either going to be growing or, we use the, you know what the other word, antithesis to growing? Decaying. So this is growing, and the other way would be decaying. So I want you to look carefully. Guess what you think might happen when the base is a half? Will it be growing or decaying? Do you have an idea before we do it? Good. We'll see, okay? Can we put in some numbers again? Tell me some x values I can put in. 1. I heard it. I'm just going to use it. What's 1/2 to the 1? 1/2. So can you find 1.5? What's another number I can put in? 2, and that's, what's 1/2 times 1/2? That's a quarter. That's probably enough going that way, right? I don't feel like plotting an 1/8 and a 16th and stuff. So, which way are we going to go now? 0. That's right. What's 1/2 to the 0? Beautiful. No one says they have their answer that everyone wants to say. So, 1, right? Now, what happens when we put in a negative exponent? What does the negative exponent do again? The reciprocal. So, what's the reciprocal of a half? So, -1 makes 2. And guess what -2 does? The reciprocal, right? So it's 4. Do you get a sense of what direction this is going? And then -3 would give you 8. This again has an asymptote. Is it possible to get a 0 or a negative answer? No. So where's the asymptote over? 0. Right? Still, all answers are positive, correct? Yes? But what's the difference of the curve? Yeah, I love the word decreasing. And for exponentials, we use the other D word, which is decaying, right? Do you see the difference between left and right? What made one grow? What was the difference between the two equations? They both have x in the exponent. What made one grow? And what made one decay? The base. So what are you learning about the base? If the base is bigger than 1, it's going to grow. And if the base is between 0 and 1, it's going to. Got it? Okay. Let's look. Hey, let's graph f of x equals 3 to the x. I just need a few points. So obviously I can plug in 1, 2, and 0. Yes? That would give me the answer 3 and 9 and 1. And I could also put in -1. That would give me a third. And then it would just kind of get silly. Where is the asymptote again? 0. So still all answers are positive. What's the difference between changing the base from 2 to 3? Is there any difference in the curve? Look carefully. So if I look at the two curves, about that curve and the one we just did, is there any difference? And the answer is it's increasing more rapidly, right? So the base, if the base is greater, bigger, it just increases more rapidly. So is this growth or decay? You know the domain for exponentials are all real numbers. What does that mean? Could you put in a negative number for x? Yep. Could you put in 0? Could you put in a positive number? Every number works. Yes for x? So that means it's all real numbers. Could you get any answer out of it? No. So all answers are positive. So it goes from 0 to infinity. Why did I put a parenthesis around 0? Because 0 is not included. Where's the Y-intercept? Where's the asymptote? We write it properly, right? You think. Horizontal, what letter do we start with? So it's y equals, where is it increasing? Everywhere. It's called monotonic, right? Left to right, it never changes direction. It's always increasing. Where is it decreasing? Never. And then how do I write down the end behavior? As x approaches infinity, what does f at x approach? Infinity. As x approaches negative infinity, so it does go to negative, but what does the function approach then? 0. You got it. It says f at x and x. We got this, Michael? Let's do this. 1/3. What's going to happen with 1/3? Where's the asymptote again? Is at 0. Can I just look at the table of values I already did and do the what? The reciprocal. So 1 is not 3, but 1 is 1/3. 2 would be a ninth, 1/9. I don't know if I really feel like putting these little fractions on. But negative 1 would give you 3, and negative 2 would give you 9. What's happening to this model? Is this growing or decaying over time? So I just took the table of values that I already did and just did the reciprocal, right? So this is decaying. The domain stays the same. The range stays the same. The y-intercept stays the same. The asymptote stays the same. But is it increasing? No, it is decreasing. So what are the two things that changed? Decreasing and it's decaying. The end behavior changed too. As x approaches infinity, now what's the function approaching? 0. And as x approaches negative infinity, what's the function approaching? See how the end behavior gets switched around? The right end is going to 0 and the left end is going up forever. Do you remember graphing these curves last year? Ish? Turn the page. Hey, as we graph this, we're going to very loosely have 2 points and know what the curve looks like rather than plotting many points. So when I see 2/5, the 1 point you always put on your graph for an exponential is 0, 1, right? Because no matter the base, if you plug in 0, the answer is 1. The asymptote will stay 0. And you might say, hey, would that ever change? And the answer is yes when you turn the page and we have transformations. If we have shifts up and down, it's going to change. We're not there yet. So you'd have to have something adding or subtracting after it that would change where the asymptote is. If there's nothing adding or subtracting at the end, it would always be 0. So I want another point. I just want 2 points and I can curve it. Do you know the base is what number? 2/5. Is that a growth model or a decay model? Why? It's less than 1, isn't it? So if it's not just a fraction, because if it was a fraction like 4/3, it would be growing, because that fraction is bigger than 1, right? It's a fraction that's between 0 and 1. So I'm going to plug in a number That's negative. Do you know what number I'm going to plug in to help me figure out how to curve this? Is negative 1. Do you know what that negative exponent does again to the base? Reciprocal. What number would that be? Which is another fancy way of saying 2 and a half. Can you find negative 1 and 2 and a half? And with those 2 points, can you curve it properly? How will it look when you curve it? Are we cool like that? We don't have to find 3, 4, 5 points? That if we find 2 points, we know the curve of the exponential? What's the domain? Good. What's the range? From 0 to infinity. Remember? Is it increasing or decreasing? It'll be one or the other, not both. There's no turning points. It either all goes down or all goes up. And what's the end behavior? So the right end goes to 0 as the left end goes to infinity. Number 4. Is that a growth or decay model? 4 to the x. Why is it growing? Because the base is bigger than 1. Why is it growing? Because the base is greater than 1. The domain is all real numbers. The range goes from 0 to infinity. The asymptote is 0 and the Y-intercept is 1. That never changed, did it? What changes is, does it grow or decay, and then increasing, decreasing in behavior. That you just have to think through. So I'm going to draw the asymptote. Y equals 0. I know the Y-intercept is at 1. What's an obvious second point I can put on my graph and then be done with it? 4 to the x. What's another point on my graph that's obvious? 1 and what? 4. Is that not obvious to plug in 1 and the answer is 4? And then what does a curve look like? Are you good with 2 points and curving it? Because the other point would be 16, and that's obviously way off my graph, right? 2 and 16. Is this increasing or decreasing? All the way, right? Never decreases. What's the end behavior? Where's the right end going? Up. And where's the left end going? Perfect. Is this starting to open a file folder up where you're starting to remember some of this? Hey, did you talk last year at all about the number E? Yeah, I'll just listen to you. I don't know if she did or didn't. In chemistry, which is awesome, do you know in math we have a number E? Do you know in math E is not a letter but a number? Did you know that? Do you know on your calculator there's a button and its purpose is to give you E? All right. So, there are 2 big irrational numbers in mathematics. Big. You ready? One you've used all the time, which is pi. Right? Where do you use the irrational number pi and it's on your calculator? To do with geometry, circles, right? To do with that area. The other one is exponential and it has to do with E. Now, E is an irrational number, just like pi. And the approximate value of it is 2.71. In your calculator, if you went E to the exponent 1 and press enter, it would go on and on and on, 2.7, and it would have, it's irrational. It goes forever, never repeats. An exponential function with a base E is called a natural base. And the reason it's called a natural base, because all my scientists out there know this, that this is what occurs in nature in terms of how a growth model. When something is growing continuously, over, the base that we use with something growing continuously is that base E. So if it's the first time you've seen it, it's okay. I want you to know that E is a number like pi is a number. Is that okay? Pi is what? Good. And E is about 2.7. It's okay, you could stop there. I'm not about that, right? When we're gonna use our calculator, we will use our calculator next 2 weeks. That when we use our calculator, we need to know where it is and use it. Sometimes we'll leave E in the answer and not use our calculator. Like, you know how you leave pi in the answer for certain things? You're going to leave E in the answer, same way. So E is an irrational number. It's called the natural base because of nature science. When something's growing continuously, we use the base E. One day when we have time, we'll tell you where it comes from. Like for pi, do you know where it comes from? Did I tell you that already? If you take any circle and you divide it by its diameter, it always equals what? Pi. It's not a magic number that came from some magical forest. Any circle, and you take its diameter and divide those two things. So if you measure the circumference, you measure the diameter and divide it, what answer do you get? And it doesn't matter if it's a tiny circle or a big circle. You take the ratio of a circumference over the diameter, you get, right? Not magical number that came from the magical forest. This is also not a magical number. And one day we'll go through it, but not this moment. Okay? So E is an irrational number, about 2.7. Yay? So if you're asked to graph it, you're going to use about 2.7 when we graph it. All right. So there are many, many real-world applications that deal with this, both financially and in science and nature where things are growing and decaying. And we're going to use that E base when doing stories as we get there. Today is not a story day. I'm sorry. There'll be another day for math stories. So, the exponential base is y equals e to the x. When you see e, is e a variable? No. Is e a variable? No. E is a number. E is a number, not a variable. And again, e is about 2.7, just to remind yourself. It's irrational, so you can only approximate it. Did I say that enough? E is a number, right? And it's about 2.7. Like pi is a number, it's about 3.14. Same idea. Okay. Hey, is E a growth or decay model? Well, E is a growth model. Why? Because the base is bigger than 1, right? 2.7. How would I graph it? Well, guess where the asymptote stays? At 0. Guess what? Even e to the 0 equals 1. So it don't matter if it's irrational or rational. Any real number to the exponent of 0 always equals 1. I want one more point. And the other point we're going to use is if I plug in 1, the answer is about what? 2.7. So find 1 and about 2.7. Yep, you're just going to have to approximate it. So obviously, what direction does it curve to the right? And then what happens as it curves to the left? It still has the same picture of an exponential, right? We're just using an irrational base. So the domain still is all real numbers. The range still goes from 0 to infinity. This is increasing all over, never decreasing. And the end behavior, as x approaches infinity, the function approaches infinity. As x approaches negative infinity, the left end behavior goes to 0. Same models we did on the first page, right? The only difference is the base is an irrational number, and about what number? 2.7. Turn the page. Now what we're going to do is we're going to graph with transformations. That means the asymptote can be shifted around if there's something adding or subtracting. So this is a review, and you're going to be so amazing at this because we did this for cube. We did this for square roots. We did this already for rationals, right? Like we've already done this hard work. Do you need a reminder of the different ways things can transform? No, it's right there, right? If you need a reminder, let's get into it. You ready? So, in order to be able to do transformations, I need to know the parent points, correct? You ready? Are you listening? Yes. Awesome. Now, this is what we're going to do. Oops. So, that is the form of an exponential. The exponent is x minus h, and then plus k follows. Do you remember I say, hey, where do I look to see how x is changing? For an exponential, you're going to look at the exponent. For an exponential, you're going to look at the exponent. For y, you're going to look in front and behind. But for the x, I'm going to look in the exponent and do the inverse. So, whatever it is, you're going to start with 0 and 1. Because does it matter what the base is? For a parent, it always starts with 0 and 1. The second one's going to be, if you plug in 1, the answer is the base. And lastly, you're going to write down y equals 0. So when I go to these questions, and I'm eventually going to graph them, this is what I'm going to start with, and then I'm going to change the 2 points, and change the asymptote, and then go to my graph. So first, can you identify the parent? The parent is just the base. So in this case, the parent would be f at x equals 2 to the x. How many transformations are here? 2 of them. What does the exponent tell me? What type of shift? And it's a horizontal shift. Left, how many? What does the subtract 3 tell me? Vertical shift? In what direction? Down 3. Let's try it again. What number is my parent? What's the base? 1/2 to the x. What are the transformations? So there's a horizontal shift in what direction? It's going to the right, how many? And then what other type of shift is there? A vertical shift, and this one's going up 1. See all these big numbers? But which is the big number that's my parent? Which is the, yeah. Which one I missed? Oh, there's a negative in front. Thank you, Michael. What does that negative do? Reflect over which axes? Excellent. Thank you, Michael. I count on you. All right. So there's 3 of them. How about number 3? Which number represents the base? -3, 4, or -7? Which one is the base? 4. So it's just 4 to the x. What does the negative do in front? It reflects on which axes? The 4, is the 4 a transformation? No, the 4 is part of the parent. What's in the exponent? What kind of shift is it? 2 to the right. And what does the -7 do? Which direction? You got it. Number 4, what's the base? E. What does the 4/3 do? Do you know that 4/3 is bigger than 1, so it's a vertical stretch? If that number was less than 1, it would be a compression. Yes?
So on number 3, we don't do anything with the 3.
Is there a 3 there? What? So the negative is a reflection. The 3 is what? A vertical. Man, I got to get my A game on. So 4. Did you hear what I said about 4/3? That because it's bigger than 1, it's a stretch. If that number was less than 1, it would be a compression. So there's a vertical stretch. Don't make a mistake again. What does the negative do in the exponent? Which axes are we going to then? So if it's in the exponent, it's the y that it reflects. What's the next one? What does +5 do? Up how many? Perfect. All right, number 5. What's the base? So it's 2 to the x. The 5 is a vertical stretch. How about the negative in the exponent? That's a reflection. And which axes? How about the subtract 4? That's a horizontal shift, and it's going to the right 4, and one more. The negative 9 is a horizontal shift, vertical shift down 9. Number 6, identify the base, 2/3 to the x. What's in front? That's reflect, and which axes? What do I see in the exponent? This one's a little bit challenging. See that 4x? That's actually what's called a horizontal compression. And the reason it's a compression is because you do the inverse. So instead of times 4, it's actually dividing, or a quarter. So it does the inverse of what it says. And therefore, if it's a quarter, it's making the x's smaller. If it makes it smaller, it's a compression. If it makes it bigger, it's a stretch. 7. What's the base? E to the x. What does the negative in front do? It reflects on which axes? The 1/2. Remember I said to be tricky here? This one's actually a horizontal stretch. And why is it? Because you do the inverse, which is not a half, but times 2, which makes the x's bigger. And then the +4 is a vertical shift up. How many? 4. One more like this, and then we're going to graph again. So what's the base? 3/4 to the x. What does the negative do in front? It does reflects on which axes? The 3, be careful, that's a horizontal compression of 1/3, because we do the inverse. +2, be careful, it's a horizontal shift left. How many? And then the -1, that's a vertical shift down 1. You guys are becoming experts at transformations, right? Seeing them doing graphs this way? Turn the page. All right. Step number 1. What's the parent? 3 to the x. Step 2. What are the 2 points for this base? And the 2 points, the 1 point will always be the same, which is if you plug in 0, the answer is 1. And the other one is 1 and what the base is, which is 3. So 0, 1 will always be there. And the other one is 1 and whatever the base is. What's the asymptote? So we are going to transform these. If I want to change the x, where do I look? In the exponent. What is it telling me to do to each x coordinate in the exponent? Add 1. So 0 plus 1 is 1. 1 plus 1 is 2. And the y doesn't change with that. How do I know how the y is changing? So what's 1 subtract 4? What's 3 subtract 4? And what's 0 subtract 4? So now my asymptote is at y equals what? So why is it not at 0? Because there's a shift that went down how many? So when I start my graph, can you find 4? 4 is the floor. Ha. Not the flower. But thank you, Chris. Then 1 and -3 and 2 and -1. What's happening to the right? What's happening to the left? Can you draw this exponential? Is this a growth or decay? So that means it's increasing and never decreasing. The domain never changes. What's always the domain? Will the range change with transformations? Yes. It changes where the asymptote is. At what number is our asymptote? So our bottom is now what number? and then it goes to where? So does the range change with the asymptote? Yes. Where's the y-intercept? It's somewhere in here, right? So to find the y-intercept, you know what I do? Plug 0 in. So if I plug 0 in, you get 3 to the negative 1, take away 4. That's 1/3 subtract 4. Do you have the number sense to go 1/3 take away 4? The answer is negative 3 and what? 2/3. What's the end behavior? So as x approaches infinity, f at x approaches infinity. How about the left end behavior? As x approaches negative infinity, what is the function approach? The asymptote, which is negative 4. Remember that horizontal asymptote gives us that end behavior. All right, number 10. Let's start. So what do you notice first in number 10? What's the base? That's the parent. I need 2 points to transform. What will be the first point always? 0 and 1. The second one is going to be 1 and whatever the base is. For this one, it might be helpful to actually have another one because the base is a fraction. What's another point that would be easier to transform? Because the base is a fraction, I didn't use positive 1, but I used negative 1, because do you really want to work with a half or positive 2, right? So we'll work with the second one here. So what does this tell me in front? And what happens after, right? So all the y's, what am I going to do? Negative 1 and then? So 1 times negative 1 is negative 1 plus 2. What's negative 1 plus 2? It stayed the same. I'm going to skip this one and go to the easier one. Do you notice the exponent didn't change, was there? Is there anything in the exponent that would change x? So it stays the same. What's 2 times negative 1? Negative 2 plus 2. So we're going to plot 0, 1 and negative 1, 0. Where's the asymptote now? So it was 0. If I go 0 times negative 1, it's always what's adding or subtracting. It's always the k. What number is k? So it's 2. So the asymptote is always what k is. Got that, k? Thank you, k. Now, what's this curve going to look like with the reflection? Did you get the curve correctly? So as it curves to the right and curves, notice it's now under the asymptote, yes? Do you see what that negative in front did? Instead of being on top of the asymptote, it's now below the asymptote. Now, the domain is all real numbers. This one you got to be tricky with because the bottom of the range is actually negative infinity, and it goes up to what number? See how I have to be careful? From bottom to top. The y-intercept is 1 still. The asymptote is at y equals 2. Is this an increasing or decreasing? Look, left to right, what is it doing? So, do you notice the base is a half, right? So why is it increasing? It's the negative in front. If you take a decay and you flip it, it's now a growth, right? So it was decay, but the negative in front flipped it. So now instead of decay, it's growth when you flip it. End behavior, what's the right end doing? It's going to the asymptote, which is 2. What's the left end doing? It's going to negative infinity. Awesome. All right, number 11. What's the base? One quarter to the x. I'm going to use the point 0 and 1. Because I have a fraction base, I'm not going to use positive 1, but I'm going to use negative 1 so that my answer is 4, and it's much easier to transform 4 than a quarter. All right, where do I see where x changes? Where do I look? And what does the exponent tell me? What should I do? Subtract 5. So can I subtract 5? And then how is the y changing? Times what number? 3. So I got 3 and I got 12. That's way up there, isn't it? Now, if I actually took 1 1/4, remember I didn't want to use a fraction? But here, when I subtract 5, when I go 1/4 times 3, it's like 3/4, right? It's kind of awkward. What's the normal asymptote? Is y equals 0. Is there anything, what number is k? Stayed the same, didn't it? So the only way that would change is if k was plus or minus a number at the end. All right, so I'm going to start with the asymptote, which is at 0. And then I'm going to find negative 5 and 3. And the other one was negative 6 and 12. That's like way up there. And then 4 and...
Isn't it negative?
What's that?
It's 4.
This 4 right here? Subtract. Should be negative 4, right? Thank you. So negative 4 3/4 is like here, right? The domain still is all real numbers. The bottom to the top, 0 to infinity. The Y-intercept, what number would you put in to find the Y-intercept? 0. It's going to be an awkward big number. It's like 3 over 4 times 4 times 4 times 4 times 4 times 4. I'm just going to write it as 3 over 4 to the 5th. I don't want to take out my calculator. 3 over 4 to the 5th. You can tell it's a very small number, right, as you're crossing the y-axis. Where's the asymptote? Listen, I'm not interested in the y-intercept during transformations. So don't sweat about the y-intercept. I care about the parent points and asymptote and transforming. Is this increasing or decreasing? Left to right. It is decreasing. What's the behavior? As x approaches infinity, what's the right end going to? As x approaches negative infinity, what's the left end going to? So when you're ready, turn the page. Aren't you glad we reviewed what you did last year on graphing exponentials? Turn the page. We got 3 more to do on graphing, and then we have a second lesson to do. Hooray! So here we go. Number 12. What's the base for number 12? E to the x. Now, we're going to use 0 and 1, and then we're going to use 1 and 2 point just for transformation purposes. And then we have y equals 0. So what's happening to the x? What does the negative do? You kind of divide by negative 1, but if you multiply by negative 1 or divide by negative 1, you get the same answer. So however you want to do it, it changes the sign, right? So 0 stays 0, but 1 becomes negative 1. How about the y? Anything in front or behind? So that means you do what it says, you add 3. Now 2.7 plus 3 is like 5.7. And then the asymptote is moved up to 3. All right, let's graph this. So I went to 0 and 4, and I approximated -1 and 5.7. Do you see the curve of that exponential? It's been reflected. The domain never changes. The range, bottom to top, the asymptote is 3 to infinity. The Y-intercept. What number do I plug in for x? Do you remember? And we even have it on there, right? It's 0 and 4. So made it easy. Is this increasing or decreasing? So as x approaches infinity, f at x approaches the asymptote, which is 3. As x approaches negative infinity, the left end goes up. All right, 2 more to practice. Then you have homework, and I'll send you the homework video so you can practice that once you finish Alex. Number 13. That's your big homework this weekend. All right, identify the base. 1/3 to the x. 1 parent point. If you plug in 0, the answer is 1. And if you plug in -1, the answer is 3. And then y equals 0. We need an asymptote and 2 points, and we can graph it from there and sketch the graph. Yes? So, can you see how x is changing? What is times 2? What should I do? Don't multiply, but divide. And then, what do I do after I divide? Sorry, I add. So when you divide after that, you add 1. Do you know what -1/2 plus 1 is? -1/2 plus 1 is 1/2. Excellent. What's happening to the y's? Just make it negative, right? So it's -1 and -3. Did the asymptote change? So it stayed at 0. So I'm going to go 1, -1. And I'm going to go 1/2 and -3. What do you think this picture looks like with those 2 points? What's happening in this direction? And as we go through here, what's going to happen in this direction? Can you see the curve of an exponential there? It's below, right, the axes. So the domain never changes. The range, be careful, it's going -infinity to 0. The Y-intercept, if I plug in 0, I get -1/3 to the -2. And I'm going to do the 1/3 first. So that is actually 9. So this is actually what number? The negative is last. So 1/3 squared and do the reciprocal. So the reciprocal of 1/3 is 3, and 3 squared is 9, and then the negative. So -9 is the y-intercept as we go through here. Is this increasing or decreasing? From left to right it is increasing. And then the end behavior. As x approaches infinity, the function approaches 0. As x approaches -infinity, it goes down forever. It goes to -infinity. All right, one more together. And then you have, I need to practice it with me. You can do that, okay? Number 14. This looks fun. So, the base is e to the x. That's the parent. So 0, 1. Remember I said approximate e is 2.7, and then the asymptote y equals 0. So 1/3. Do you know what I do? The inverse of that is times 3, and then subtract 2. So 0 times 3 is 0. Subtract 2, and it's -2. Do it again. 1 times 3. 3, subtract 2. So can you follow what we did, right? The inverse of what I see? Hey, the only thing with the y is we subtract what? 1. So now the asymptote is at y equals -1. We have negative 2 and 0. We have 1 and 1.7. So 1 and 1.7. See, the 1/3 is a horizontal stretch. So what does the picture look like if you horizontally stretch it? You know what I mean? Like what? Can you picture that exponential that's been stretched sideways? That's kind of what it is. So those 2 points are stretched sideways as it goes across. The domain is always all real numbers. The range goes from from -1 to infinity from the asymptote. The Y-intercept, if I plug in 0, would be e to the 2/3 subtract 1. That's fine. I'm not going to have you take out your calculator. E to the 2/3 subtract 1. This is always increasing. It is never decreasing. And the end behavior. The right end is going up. The left end is going to the asymptote, which is at -1. All right, there's your lesson on graphing exponentials. Mr. G Math, over and out.